Welcome, stargazers. Can you believe it? Picture a celestial event so colossal that it makes unseen regions on Earth visible without even trying to hide. That is the spectacle we may be on the brink of witnessing. In the Orion constellation, the star Betelgeuse is behaving mysteriously, hinting at a coming cosmic explosion, a supernova, that will illuminate our sky like never before. But when will Betelgeuse go supernova? And what will it look like? What mysteries might this grand event uncover? Join us as we delve deep into the details of what's truly happening with Betelgeuse and the impact it could have on Earth and perhaps the entire nearby planetary system. Located about 650 light-years from Earth in the constellation Orion, Betelgeuse isn't just any typical star. It's a red supergiant, perhaps one of the most luminous stars known to us, shining with a brightness over 100,000 times that of our Sun. But why does this red giant matter so much to us? Betelgeuse stands out not only for its brightness but also for its history and significance in human culture. Named after the Arabic expression Yad al-Jaz, which means the hand of Orion, Betelgeuse has been observed and recorded by ancient civilizations for thousands of years. It has served as a guide for travelers and a source of wonder for stargazers, its reddish hue distinguishing it from other stars in the Orion constellation. Can you imagine a single star outshining our entire solar system? To put its sheer size into perspective, if Betelgeuse replaced our Sun, its edges would stretch all the way to Jupiter. How can a single star achieve such colossal proportions? At only 10 million years old, it's much younger than our 5-billion-year-old Sunday. However, Betelgeuse's massive size means it burns through its material at a much faster rate, giving it a shorter lifespan than smaller stars. Now, this celestial giant, occupying a volume large enough to contain more than 1 billion suns, is nearing the end of its life cycle. When stars of such magnitude reach their twilight years, they don't simply fade away. They exit with a spectacular bang, a supernova explosion unleashing unimaginable energy and brilliance. Such an event has the potential to outshine an entire galaxy, casting regions of brightness across vast cosmic distances. The last time Earth witnessed a supernova this close was in 1604, well before the advent of modern telescopes. This event, known as the Kepler supernova, was the last supernova observed in our Milky Way galaxy with the naked eye. It remained visible for over 18 months, brighter than any other star in the night sky, and could even be seen during the day for several weeks. What secrets do these celestial remnants reveal? Ancient records from civilizations, including Chinese and European astronomers, documented the presence of this new star. Fascinatingly, remnants of this explosion, in the form of an expanding debris cloud, can still be observed today using advanced telescopes, offering insights into the violent deaths of massive stars. While supernovae are rare phenomena for earthly observers, imagine a cosmic explosion so intense that it rivals the brightness of a full moon, casting shadows on Earth at night and being visible during the daytime. The radiation from such an event could electrify our atmosphere, potentially affecting satellite operations and even our climate. Betelgeuse, with its erratic dimming patterns, suggests it might be preparing for just such a grand spectacle. Could we be on the verge of witnessing one of the universe's most dramatic events? Recently, astronomers made a groundbreaking discovery. Between October 2019 and mid-2020, Betelgeuse underwent an extraordinary transformation that captured the attention of countless scientists and enthusiasts worldwide. Known as the Great Dimming, the star's brightness, which had remained steady for centuries, began to diminish significantly. This sudden change was so noticeable that even casual stargazers observed it, comparing Betelgeuse to other stars in the Orion constellation. This phenomenon led many to believe that we might not just be decades away from witnessing its supernova explosion but perhaps only years, or even less. By April 2023, astronomical observations revealed that Betelgeuse had returned to its normal brightness level, leading many to think that the period of irregularity had ended. In a surprising twist, however, the following months saw Betelgeuse's brightness increase by an astonishing 50%. Such dramatic fluctuations, while typical for variable stars, were unprecedented for Betelgeuse, which had predominantly exhibited predictable brightness cycles. Outrageous! The flood in its splendor pushed the star once again into the spotlight, igniting discussions about its short-term behavior. Yet what caused the unexpected change in splendor? For what reason did Betelgeuse, quite possibly one of the most unmistakable stars in our night sky, unexpectedly throw a divine curveball? Stars are not merely gleaming dots in our night sky. They are dynamic entities with life cycles, activities, and secrets of their own. For some celestial bodies, periodic variations in splendor can be predicted, much like the rhythms of Earth's seasons. Throughout its celestial lifetime, Betelgeuse has maintained a fairly consistent multi-decade iridescent cycle. However, with the recent dimming, it appeared to challenge its established behavior, testing our understanding of the phenomena above. Now, you might be wondering, are we approaching a glorious revelation? While the specific reasons for Betelgeuse's irregularities are still under investigation, a compelling theory has emerged. This theory, focusing on celestial activity and mass ejection, presents a fascinating scenario. Imagine Betelgeuse as a massive stellar volcano, subtly ejecting enormous amounts of its material into space. Past observations from the Hubble Space Telescope revealed that Betelgeuse had recently expelled a significant portion of its surface material into the cosmos. This ejection, an extraordinary event, was 400 billion times the mass typically released during similar solar phenomena, equivalent to several times the mass of our Moon. Such events can lead to the formation of a dense dust cloud around the star, affecting its apparent brightness and temporarily making it more challenging to observe. Then, as this dust dispersed or was pushed away by the star's radiation pressure, the veil lifted, explaining its return to normal brightness levels. These new events suggest that Betelgeuse is far from done surprising us. Many speculate that it may be nearing the twilight of its life, a supernova event. This spectacular burst of energy, capable of outshining an entire galaxy, occurs when there is a sudden change in the star's core. Such changes may arise if a star absorbs too much material from a neighboring star or, in Betelgeuse's case, from the exhaustion of its nuclear fuel, causing its mass to collapse inward in preparation for a catastrophic implosion. But what drives a massive star like Betelgeuse to its end? Stars like Betelgeuse begin their journey by fusing hydrogen in their cores. This initial stage, known as the main sequence, lasts for millions of years and forms the foundation of a star's life. However, as stars exhaust their hydrogen supply, they expand and take on new energy sources. In Betelgeuse's case, as hydrogen depletes, it begins to burn helium, leading to the formation of carbon and oxygen. This transition from the main sequence to the helium-burning stage marks the star's evolution into a red giant. Over time, as helium continues to be consumed, the star undergoes further expansion and shifts into other burning stages, each characterized by the fusion of progressively heavier elements. The larger the star, the faster these transitions occur, due to the immense gravitational pressures at play. Then comes the climax, when iron begins to form at the core. Unlike lighter elements, iron does not release energy when fused, and the energy produced is no longer sufficient to counter the star's crushing gravity. The star expands in size and undergoes a collapse, followed by a massive rebound explosion, resulting in the catastrophic force of a supernova. So, is Betelgeuse on the brink of an unstable demise or merely biding its time? Recent research by Japan's Tohoku University suggests that the star may currently be in its carbon-burning stage. Lead scientist Haydock believes that the core could collapse decades after its carbon reserves are depleted. Yet not all researchers agree. Contrasting studies from Hungary's Konkoly Observatory hypothesize that Betelgeuse is still in its earlier helium-burning stage. One point that all scientists agree on, however, is that Betelgeuse is destined to become the Milky Way's next supernova. Pinpointing the timing of this event, however, remains an endless guessing game, with predictions ranging from decades to 100,000 years. Amidst these scientific debates and speculations about Betelgeuse's fate, one fact remains uncontested: the nature of our observations. When we look up at the brilliant sky, there's a subtle irony we often overlook. This mystery is rooted in the nature of time and light itself. In our vast universe, stars and celestial bodies are so distant that their light takes an immense amount of time to reach us. For instance, the speed of light, while astonishing at 186,282 miles per second, still has its limits. As a result, the light from distant stars and galaxies takes years, sometimes millennia, to traverse the expanse of space before it reaches our eyes. When observing Betelgeuse, you're actually seeing an image from 650 years ago. This means we're always experiencing the past, not the present when gazing at the sky. So, even if Betelgeuse were to go supernova, the light from that explosion might not reach us for decades or even centuries. In fact, some scientists have even wondered whether Betelgeuse has already gone supernova and we're simply waiting for its light to arrive. Alternatively, as some researchers predict, this event might occur far in the future. So, how would we truly witness the death of a star like Betelgeuse if we are perpetually looking backward in time? This paradox highlights the remarkable complexity and beauty of our universe. What makes this so extraordinary, however, is how our history will forever be linked to such rare cosmic events. When Betelgeuse reaches the end of its life, we won't just witness the death of a star but also a moment in time that connects us to ancient beginnings, when humanity first gazed at the heavens in awe. In that moment, we will understand something profound about our place in the universe. As we anticipate Betelgeuse's inevitable supernova, it serves as a reminder of the transient nature of the stars that light up our sky. Just as our sun will eventually meet its end, so too will this brilliant red giant. Unlike our sun, which will conclude in a much quieter fashion, Betelgeuse's explosive finale promises to be a grand spectacle. The energy released in a supernova could be enough to trigger a chain of events that might affect the surrounding universe, sending shockwaves through space and even influencing nearby celestial bodies. While it's true that such an event could disrupt satellite communications or generate radiation capable of affecting life on Earth, astronomers agree that the likelihood of Betelgeuse's explosion causing catastrophic consequences for our planet is very low. The distance between us and Betelgeuse, 650 light-years, is sufficient to shield Earth from any direct harm. Nonetheless, the knowledge that we could witness the explosive death of a star is awe-inspiring. It serves as a reminder that the universe is a dynamic, ever-changing place, where even the brightest and most stable stars are bound by the same natural laws of birth, life, and eventual death. If the supernova occurs within our lifetime, we will have the rare privilege of observing an event that no human has ever witnessed before, offering us a glimpse into the immense power and vastness of the universe beyond our wildest imagination.